And you will be able to find this recording in the wrap-up tab after this event is over. So if you go to the event page, you will see a tab called Wrap Up, and the recordings will be there available for download. Okay, so today's session will be focusing on testing strategies and best practices using MUnit. And I will be your facilitator for the session. And Jimmy and Lakshmi are both from MuleSoft, and they're going to do an in-depth demo and presentation about best practices in MUnit. So a little bit about myself. I am an API and integration specialist from Suncor, and I've been working with MuleSoft for 2 years now. And I am always looking forward to improving my MuleSoft knowledge and using best practices, so to be the perfect session for me. I like to start with the safe harbor statement, which is please do not make decisions solely based on this presentation. You still need to consult with your customer success manager and your internal team before you decide to make purchases of any kind related to MuleSoft. So don't just depend on the information that is presented in this session today. I'd like to go through the agenda, which is I've introduced myself, and I'll let Jimmy and Lakshmi introduce themselves right now. So if Jimmy, you want to go first in introducing yourself?
Yeah, sure, Mandy. So hello, everyone. Welcome to the first virtual Mandy Calgary's area. My name is Jimmy Atiyah. I'm a strategic advisor with MuleSoft strategy and architecture team. I have been working with the MuleSoft for more than a year now. And before that, I was leading the MuleSoft integration team in one of the MuleSoft customer organization for 5 years. So I have got the chance to use the MuleSoft platform as a customer and got to see and experience firsthand the challenges and the MuleSoft implementation that some of our customers go through as well, which helped me a lot when I moved to MuleSoft. So that's about me.
Thanks, Jimmy. And Lakshmi, do you want to introduce yourself?
Yep. Hi, everyone. Welcome to the meetup. My name is Lakshmi Narayan. I'm part of the same customer success strategy and architecture team at MuleSoft. I'm a technical consultant. So I work with customers, to ensure they have the right technical and strategic guidance so as to be successful in their implementations. My goal is to maximize the value that customers get out of the platform. And help them and enable them on product features that will be helpful as they continue their journey with MuleSoft. I have around 12 years of experience in various integration domains. So thank you for joining, and hopefully this will be helpful for all of you.
Thanks, Lakshmi. And I like to go over the meeting logistics before we dive into the content. So no one will be able to speak unless you are a host or a presenter. So no one but the three of us will be able to talk. If you have any questions during the meetup, please put it in the chat, or you can direct message me. Either way is fine. And I like to stress the importance of paying really close attention during the meetup, because there will be 3 trivia questions scattered throughout the session. And the first person who is able to write the correct answer in the chat will win a prize for each question. And the prize is a free MuleSoft training of your choice. So that's really good prize. Please pay attention. and we'll announce the winners at the end of the session after the Q&A. So Jimmy and Lakshmi, I think you can take it from here regarding the importance of testing.
All right, thank you, Mandy. Before I start the topic of today, I want to thank Mandy from Suncor Energy integration team for facilitating this event. Thank you, Mandy. And as she said in the beginning, this is the first virtual meetup in Calgary, and I would really like to have like a cadence of virtual meetups in this area. So if you have ideas or topics that you would like to add to the agenda of the future meetups, please suggest them in the chat section, and I will collect them and contact you. Also, if you would like to speak at any of the future meetups, that will be most welcome. Just post your name, email, and a topic that you would like to talk about in the chat section, and I will contact you. Speakers of virtual events don't have to be from MuleSoft all the time. We welcome our customers and partners to participate in those meetups and share their experiences. So with your help, we can build a backlog of topics for future events to keep the momentum and maintain a cadence for those meetups. Maybe we can make it like once every quarter or even monthly if we can have enough backlog of topics and speakers as well. It's really useful for our customers, especially in Alberta, to meet virtually and exchange experiences. I always hear from our customers, especially from Edmonton, that they experience a shortage of MuleSoft resources. So this type of event helps in building connections and expand the professional networks. So I'm looking forward to your suggestions and participation. Thank you all. Again, as Mandy mentioned, throughout this meetup, we will be asking, both myself and Lakshmi will be asking 3 trivia questions. So the first ones to post the correct answers in the chat section will be getting free training from MuleSoft, training of your choice. The questions will be based on topics that we'll be covering throughout this meetup and slides. So if you pay enough attention, the answers should be very easy for you. During this meetup, I will go through the different types of and phases of testing and the importance of each, and I will talk at a high level about the MUnit. Then I will pass it to Lakshmi to cover the technical part and go through the demo as well. All right, as Mandy said, if you have any question, please post it in the chat. She will be helping me collecting those questions, and then at the end of the presentation, we will go through those questions together. All right, so let's get started. Can you still see my screen?
No.
No, I'm not able to see your screen.
Let's try again. Can you see it now?
Yep.
Yep.
All right. So let's start the topic by the definition of testing. So what is testing? And here we're talking generic terms. So testing is basically taking measures to check the quality and performance, reliability of something, anything, especially before putting it into widespread use or practice. And how the testing applies to the software world and specifically for MuleSoft, we usually have go into two streams of testing. One is pre-go live and the other one is post-go live. The pre-go live, we actually go through the entire components of the system and make sure all pieces of the application work separately, work perfectly on its own, and then make sure, which we call it unit testing, and also make sure that all pieces of the application can work together. Sometimes we call it system integration testing or SIT. After we go live, there are other types of testing that we can do, like ensuring that when we deploy the application, it still performs properly. And again, after deployment, the application can still take out the load and it's sized properly to handle the function it meant to be functioning. Why we test? What is the importance of testing and what could happen if we didn't test? We can think about the importance of testing from 3 angles: the cost, the assurance, and the competence. If we don't do any types of testing, what would be the cost? So what could be the cost to fix a defect after a release? What could be the cost to debug or trace certain issue if we don't have unit testing? Also, what could be the cost to deploy a new release or fix a bug or add a new feature to our application, and we don't have regression testing or automated testing? If you think about those type of questions, you will really realize the importance of testing. Also, from the assurance side, if you really work in an organization that they follow like release management process or ITIL or something like this, you need to provide some level of assurance that what you have created and what you're about to deploy to your production environment has like a base acceptance, like has run through basic testing and gone through the due diligence, and it is ready to release. So you can give the functional manager or the release manager the good informed decision that this is a good thing to go. From the competence, if you are following the CI/CD within your organization, you really cannot do CI/CD, continuous integration and continuous delivery, for any future releases without having automated testing. So testing is really something very important, very crucial, and it's really weaved within your software development lifecycle, as we will see later on. Let's now talk about the phases and the types of testing. So this slide talks about the basic types of testing, or the minimum that every software developer and every software organization should think about. First, we would start with unit testing. Basically, we're testing individual components. I'm going to talk about those in details in the future slide. Second is integration testing. Make sure that the units talk together. Performance testing. Make sure that the system can take the load, the expected load that was captured during the requirement gathering process. Also, user acceptance testing, which is testing to be done by the system user themselves. So let's go through each one of those in a little bit of detail. So unit testing. The first phase, what is unit testing? As we talk like testing the individual units of code, make sure that every piece of code or every function of code actually does what is meant to do, and it works as expected. Who usually does this type of testing? This type of testing is usually performed by developers and while they are doing their code. So as they receive the requirements, they can identify units, and then they can start coding the unit testing. Some organizations go through like test-driven development, which they create the test first, and then they go ahead and develop the code. So no matter, or regardless of the methodology you're following within your organization, you have to have unit testing to test each individual component. Why this unit testing is important? So you want to make sure that the individual pieces work together as expected. You want to make sure that this is like kind of the base. The base is working fine because you put these components together. So unit testing is like a foundational piece in the whole entire experience of building like automated testing with to your application. The next type of testing is the integration testing. We call it like system integration testing, or SIT. It's like kind of combining the related pieces that we have captured together to make sure that they work together. Here, basically, we're testing the connectivity between the individual components. Sometimes the system integration testing include the front-end application. So if you're building layers of APIs, integration testing, like if you're following the API led, for example, integration testing means that I am testing the integration between the different layers. I can make sure that the process layer can speak to the system layer, the experience layer can speak to the process layer. And even if I have built a custom app or a mobile app or a web application on the top, or even the custom code that's using the API, it's up to you to include it in this phase of testing or not. Sometimes it's included. Why we're doing, who's doing this type of testing? This is typically done by technical end users of the applications, like maybe like members of your quality assurance team, or if you have a dedicated team to do it. Whoever is doing the system integration testing doesn't really need to understand the internal details of the application. So I don't have to understand how this API is functioning or what exactly this application is doing, but they need to understand generally deep knowledge about the application functionality itself. I need to understand in a nutshell what should be the output for this particular API if I supply this particular input. They should be having this level of understanding. Why the system integration testing is important? It's the first phase of testing where the application functionality is truly tested. This is where you can say that, yes, the layers I built or the different components that we developed in different, or maybe sometimes by different teams, now they can integrate and talk to each other. Also, it makes sure that the data flow between the different components of the system is going very well from one piece to another without any problems. Next type of, or next phase of testing is the performance testing. So the performance testing is a very important phase to ensure the performance of application is in line with the requirement. And it's here basically, it's an opportunity to talk about the non-functional requirement, which is sometimes it's overlooked when we start gathering the requirement of a specific application or a specific API. Sometimes we overlook this part, which is very important. So if you're following like a waterfall or agile, if you have a product owner or a business analyst, those questions needs to be asked to the business and you need to have answers for them. What should be the response time for every API? Are we expecting the API to be responsive within milliseconds, or if it is live, or maybe if it's a job like running behind the scene, maybe like it doesn't have to be responsive, like nobody's actually waiting for a response, it's just moving data from one location to another. So this question should be asked. What is the payload size? Are we expecting a lot of small and frequent transactions through this API, or are we experiencing like larger payloads that comes like infrequent, maybe once in an hour or once in 2 hours, or maybe once a day in case of you're doing ETL. So payload size or average payload size should be important as well. How many requests of this application receive? Is this like exposed to a mobile application or a web application or an external partner or vendor where we expect to receive a large amount of transactions per second? Or as I said, like this is something happening in the back end that maybe runs once in a while. That's important. How many concurrent users? Like if this API is exposed for a mobile application, for example, and this is like kind of public mobile app, then we expect a lot of transactions per second. However, if we're exposing an API to a partner to do some kind of business transaction or EDI or some like kind of business-to-business communication, then it might not be that frequent. So we need to collect this information as well. Will there be any spikes in the usage or no? So should we expect the system to be quiet most of the time, and then at a certain time where the job starts, we get like a spike of usage, maybe a larger payloads coming or like large number of transactions? Like if you are in the retail business, like especially in like around Christmas time or those type of events where we expect large amount of volume, like have we done testing across that? Have we captured this information? Have we said like our API should handle at least this number of transactions per second? So all of those questions should be discussed within the development and business team, and all of those questions should be collected and per API. And you need to consider the level of API as well. Like for system API, it's different than process API, it's different than experience API. Sometimes when it's system API and it's mostly used and it's mostly reused by the different application of the system, we could expect larger payload that might affect the system of record that we are abstracting. So this is very important to consider. So when we talk about performance testing, there are types of performance testing. The first one is the load testing. Load testing is measure the system performance as the workload. So either number of concurrent users or number of transaction or testing against a certain payload size. This test helps you to understand the application response time as like kind of for example, let's say this system should operate, the minimum number of transactions per second is this, and the maximum number of transactions is, let's say, 100 transactions per second. Then the load testing should be testing against the 100 transactions per second. If we're expecting a minimum size of payload, like a few bytes, and then the larger payload size could be like 10 kilobytes, for example, then the load size, the load testing should test against the 10K. Make sure that that your system is tested against the max load that you have. The next type is stress testing. So stress testing is measuring the system performance when the number of users or transactions are beyond the normal working parameters. So if you're experience like between a minimum and a maximum number of users, stress testing is going beyond. I'm trying now to stress the system and check what is the breaking point of my application, when the application would break, when I'm gonna start seeing memory leak, when I'm gonna start seeing CPU issues. So this is the kind of the breaking point. So you would know the capacity from within your application can operate. This is very important to capture as well. Last two types of performance testing is spike testing and endurance testing. What is a spike testing? Spike testing is a form of testing to measure the system performance when the workload suddenly increase quickly. And two examples in this case, like if you have like an ETL job that runs every night to move millions of records between like your database and Salesforce or between your internal systems, this is what we call a spike testing. I mean, this is an example of a spike testing that you should measure as well, like a certain increase in the transaction in a very short time, right? And this will help you like understand if your application is gonna stand the load when you're doing ETL or no. This is like need to be adjusted, and it also help you come up with the proper sizing for your application. Is it one core is enough, 2 cores enough, or more? This is the right test to do. Endurance testing, it measured the system performance at the normal workload, but it at an extended amount of time. So it's like the normal operating hours. I'm just having an eye on the system, like maybe for a 2 hours or 3 hours, and getting a snapshot of how the system operates. Like this is like kind of will surface any issues that may be blocking the system or your application to work properly under normal operating circumstances. This type of testing is very helpful. And sometimes we do this on production as well. Like you want to make sure that you want to capture the production load at a certain amount of time over a longer period of time and see, yes, the system works perfect, or no, there is some adjustments needs to be made. Performance testing. Who does this testing? It varies. Some organizations have their integration team to run the performance testing, right? Some organizations hire a dedicated team to run their performance testing, because really performance testing is very important, especially if you're planning to scale your application network. Sometimes when we start with MuleSoft building integration between two apps, I just need to connect these two applications. I want to move data between these two applications. So performance is not really a big issue. But if you're following the API-led methodology and the reuse, what you're building now should be reused in the future. So the API that you built originally, maybe as a proof of concept or a pilot project, now it has a great use. And now other people within your team start to reuse this API. So all of a sudden, you're going to find an unexpected workload coming through this API. Oh, but this wasn't like kind of taken care of from the beginning. Yes, because we haven't considered the performance testing from day one. Always be future thinking and capture this information as you go. Important, as I said, like important, we already discussed the important. I don't want to spend much time in here. But again, the bottom line of it is to surface any issues that might affect your memory or CPU or anything happening behind the unusual behavior. You can or capture it while you're performing the different types of performance testing. Last type of testing is the user acceptance testing. This is the last phase of testing. We call it UAT, where the end user of of your application is actually coming and try to test your application or your API using real data. So, right, usually up till this point, developers and QA start to do some dummy data just to make sure that everything and connectivity works. But this phase, a real user coming and using real data and make sure the system like works as expected on production. Usually in this case, they're doing like kind of end-to-end testing, meaning that I'm testing the front-facing application. If I'm building like an application, web application or a mobile app, all the way until the database, going through all the layers of APIs. So this is like kind of end-to-end testing. This type of testing is typically done by non-technical user, more of business users. So sometimes I've seen organization hiring a team of a business user, they put them in the room and then they give them access to the system and they, hey, try to run your normal data through the system and capture your observation. And we will come back and go through it and see if the system can behave exactly like production or not. Why it's important? It's the first time the system is actually tested in scenarios where it's actually production-like. It's real data and full data is being tested. The user who's doing the testing are like kind of business user who will validate the scenario and make sure this is the exact end user experience that is expected. So this is very important. And usually it's done in a UAT environment, and it's a production-like environment. So you're exactly mimicking what's going to happen in production. Now let's switch gear and talk about where testing fits in the API lifecycle. So this diagram shows the different API lifecycle. The API lifecycle with the different phases, and show you how the Anypoint platform could help you and support you in every one of those phases. I'm not too sure if you can see my mouse, but here let's start with the design phase. Design phase is where you usually start thinking about your API, what you're gonna build, how the contract looks like. You're gonna start using the API designer to start crafting your RAML or Swagger or whatever type of platform that you would like use, and you're gonna start crafting your API, right? After you're finished, this job is being done by the developer. After this, the developer will like kind of turn on the mocking services. The mocking services will generate a link. So this link simulate actually as if the API is actually functioning behind the scene. And if you hit this link, a sample JSON file or XML or whatever like kind of format the API tend to produce, it's going to give you a sample. In this case, you can get feedback from the API consumer. Hey, is this what you're expecting or no? Is this the right output that you expect or no? Is this the right amount of field, or I'm missing something or no? And then it goes through the validation. If something needs to be added, again, it will go through the API designer, and then we'll keep going through the design, simulate, feedback, and validate until the API is really good to go and it has been approved by the different stakeholders. Then developer will take the API into Anypoint Studio and start building the API. On the left, like bottom left side, is the important piece that is the main topic of our discussion today, is testing. So here MUnit help you to achieve this testing objective. It help you building your MUnit testing. It help you building your automated testing. You can incorporate them in your CI. This in the next slide. But this is basically where fits in the API lifecycle. After you're done, you're just going to publish your API on the API portal, or now it's Exchange, and now the API can be consumed by the stakeholders or the API users. So testing is very important piece in the API lifecycle. So where testing fits in the CI/CD, continuous integration and continuous delivery. If you look at this diagram, I'm just going to show you the full diagram in here. So this is an example of a continuous integration and deployment scenario. So this is just an example. Like it's like kind of fancy, like the ultimate case that you may see into your organization, or this could be like a model that you can aim to achieve if you don't have it already. So the process starts in the development environment. It starts when the developer checks out the project or checks out the code, import it into the Anypoint Studio, and start working on it. While working on the Anypoint Studio, the developer will start creating unit testing and integration testing, right? And again, we're going to go through the details of how to build MUnit and integration testing, and this is Lakshmi is going to go through this in the demo. But basically, while you're doing the code, you're actually investing the time to write unit test and integration test. And this is very important piece, because sometimes the developer is rushed to get things done. They are under the pressure or a certain timeline that they need to finish. They just do the code without paying enough attention to the unit testing and integration testing. And this will create too much work down the road if it hasn't been captured and dealt with during the development phase. After the developer is finished, they will just check in the project. Check in the project if your source code management system is linked to your integration server, then the integration server represented in Jenkins, in this case, will get triggered. We'll grab the code and then build the code using Maven dependencies, grab the code, build it, and then run the unit testing and the integration testing. And then if everything goes good, then it will create a build and push it into your artifact repository. All right, I'm in step 10 right now. Step 11 is like kind of fancy, but really good, is once the deployment reach the repo, it will open a ticket in a ServiceNow. You could be using Salesforce, ServiceNow, or any internal ticketing system, but basically, here you will get a notification that this application is being deployed to QA, went through all the processes, and now the build is good to go. All the integration and test unit testing has been run successfully, and now it is ready for the next step. Sometimes this kicks in an approval process within ServiceNow where the right person gets a notification that, hey, everything is good in QA. Do you approve the next step? If this person gives approval, then it goes to the next step. Jenkins will grab the file again, deploy it again, create a UAT build, and then apply it to UAT environment and send another ticket to ServiceNow saying, hey, log the ticket first that this is like kind of something happened, because if you have a strict release management process, they need to keep log and audit for every single phase. So step 14 will just leave a notification and create a ticket that everything looks good on UAT. Usually when thing goes UAT, sometimes it's very rare that there is like kind of automated process between UAT and prod. Sometimes like somebody manually has to approve the last step to go to production. If this approval being granted, then again, Jenkins will grab the code from the previous environment and then push it to production, and then add a ServiceNow ticket that this particular release with this particular number has been released on production on this specific date. And from auditing perspective, everything is logged, everything is automated. Like if you can see in here, it's like very minimal human intervention. It's only throughout the approval process, which could be automated as well. But this is basically the ultimate case where you should achieve within your organization. Those tools are just examples, like GitHub here and Jenkins and Artifactory and ServiceNow are just examples. But here we're talking about approach and a process. We're not talking about tools. So don't think about the continuous integration process as a tool that I'm using. No, continuous integration, continuous deployment is a development approach regardless of which tool you're using. So you could use whatever tool to achieve the same target. Now it's the time for trivia question 1. I hope everybody was paying attention. So I'm gonna go through the question. And then if you know the answer, put it in the chat. The first one to put the right answer will be the winner for this question. There are other 2 questions coming along the way, but let's go the first one. We will not announce the winner now. We'll just grab the information and then announce it at the end. So I just go through the question, give it a minute, and then we'll see your responses. Trivia question 1. What is a form of testing that measures system performance when the workload suddenly increase. I mean, quickly increase. Is it the load testing? Is it the stress testing? Is it the spike testing or the endurance testing? All right. So answer A, B, C, or D. And the first one will be the winner. Okay. Great. I'll just give it 30 seconds and then we'll move ahead. I think we already started to receive answers. Okay, let's move ahead. Okay, now I will speak at a high level about the MUnit. MUnit is basically a framework by MuleSoft to address mainly the unit testing, right? So the purpose of the unit testing, as we discussed earlier, is to validate the correctness of individual units of code. Every individual unit of code should be tested, and at its like we think about the testable unit as the smallest testable part of your application. All right. The smallest part could be a processor, could be a flow, could be a subflow, regardless. It's just the smallest unit of testing. What is MUnit? Like, what is the definition of MUnit? And please pay attention here. MUnit is a MuleSoft testing framework. It tests the Mule flows in an embedded Mule runtime. It allows the developers to automate the testing, different types of testing. It is fully integrated with MuleSoft Studio. Design and run similar to MuleSoft applications. So if you have built MUnit testing before, you just deal with them within the Anypoint Studio regularly as if you're working with regular MuleSoft applications. It is fully integrated with Maven and Surefire for continuous integration. It provides the ability to mock different Mule components. And mocking here is a big component of MUnit because you need to break the dependencies. It provides the ability to mock the different different Mule components so that the test cases can be constrained and isolated. Okay, so why do we use MUnit? People may ask, why should I use MUnit? Why I don't just go with other types of units that maybe can use whatever being used in Java or anything else? Why MUnit specifically? MUnit is native for Mule. It's built to work with MuleSoft. It provides you different features. One of them is Mule Coverage. Mule Coverage is basically telling you how many components of your flow has been tested. It gives you a report at the end, which is very useful. It tests the Mule application in Mule code, like similarly like working with Mule apps. It uses the same IDE or user interface for developers to debug and test. So it's very native. It's easy to learn and use. Again, it's built within the Anypoint Studio. So same way you navigate it, same way you navigate any project. It's if you know MuleSoft, it's native to you. It's easy. It takes care of the basis. It can generate test suites for you. Like if you're using MuleSoft within Studio, the MuleSoft API kit can generate the unit testing for you. Any junior developer with little experience can use the user interface because you're not actually building code. You're just dragging and dropping from the palette and just doing some configuration. You're not actually doing any coding. It helps in operation and support. It's extensible to use plugins. Maven is a very famous plugin that we use for MUnit. It's a dependency framework. It tests as a part of, it uses MUnit. So we use Maven to trigger the MUnit test in the continuous integration environment. So it's very, very useful from operation perspective. How MUnit is used. So now if you start building your MUnit, what are the steps? First, you need to identify the units of code that to be tested. You need to create the precondition and post condition. So Lakshmi will show you how to do this. I'm just going to go through it very quickly. You need to define the logic of testing. You need to start executing the testing, and then you need to review the report and the result of the unit testing and see if you have a good coverage, if something goes wrong or something needs adjustment. It goes through that. I want to go through two scenarios of testing. Usually, lots of people does the positive testing, which is like the standard. Positive testing is like I'm testing the successful path of my application. I'm just gonna state the condition to be tested. I'm just gonna identify the input data to be tested. I'm just gonna define the range of values of the data that will execute the scenario successfully. I just gonna identify the output range of values that will be successful as an successful output for the application or API. And then I'm gonna start mocking the components that relies on third-party application. Like for example, if there is a database, if you're calling a database, if you're calling an external API, you need to replace this call by inserting a mockup component and put like kind of hard code inside it, so it's very expected. All right, and then you run through the successful execution. So this is the positive scenario. The important type that sometimes gets overlooked is the negative testing scenario. In the negative testing scenario, we basically focus on the cases where the API might break or the application could provide errors or go through exceptions. So this is basically like in this, like it needs a lot of like kind of brainstorming and see what could go wrong for this particular API. You need to define a range of values that if I provided those values as an input to the API, of course, I'm going to get an exception. All right. You need to identify what types of error that could be arise from this API. It could be error in the input, like sometimes an API would expect like a Boolean variable or a Boolean value. I'm just putting a string or putting an integer or putting whatever. So I'm breaking the API by providing a wrong input. That's a user error. Sometimes it's a runtime error, like the API is trying to connect to a database or an external component and it's not responding or down for whatever reason. That's a runtime error. So those types of error has to be identified, and you need to provide error codes as well if you're building RESTful API. You need to provide a range of wrong inputs and a range of outputs, and you need to pay great attention to how are you going to capture those errors. Are you going to log them? Are you going to send them to a database? Are you going to send them to your like kind of an external system? But within the negative testing scenario, you want to make sure that the errors are being captured, and also you want to make sure as a developer that sometimes developers get into the habit that if something goes wrong, I'm going to log the payload. So logging the payload all the time is not a best practice. Sometimes the payload have some sensitive information or PI information that shouldn't be logged. So don't, as a best practice, when you catch yourself logging the whole entire payload, that's like kind of a regular practice. Take it like as an advice. Don't do that. Just log the minimum that would help you or help whoever the operation team and support team to trace and identify the error. Don't log everything. This is the negative testing scenario. MUnit test coverage. So MUnit covering feature gives you the measurement of how much of your application has been executed by MUnit testing. It gives you like a count, and it gives you like how many, it gives you a report at various levels, at the application level and at the resource level and at the flow level. At the application level, it gives you like an average, how many items within your applications, how many items or processors within your application are being tested or at least covered by the MUnit. It gives you on the resource level as well. So your API has different resources, like it gives you this level of detail as well. And it goes through each flow as well. Like each flow and each subflow and give you this level of details. So this is very useful. Typically, we are always looking like the good range is between 70 to 80%. So make sure that you have at least 70 to 80% of your code is covered by MUnit testing. This is like kind of the happy range. Test scopes. So this is like kind of screenshot of what you're going to see when you start your testing suite. It's divided mainly into 3 scopes. It's behavior, execution, and validation. So in the behavior, we set all the preconditions. So if your API needs to be primed by having a certain values or something that is expected or something that you need to run before you run API, everything is done in the behavior. The execution is the logic of testing, what exactly you want to test, and the logic itself in here. And the validation, it's just go through all the validation, which makes sure that our testing is like kind of mid the expectation. It's like Lakshmi will go through this and show you how to do the assertion and the validation in this section. The anatomy of the MUnit. Let me open it all for you. Okay, so what is the anatomy of test suite? Test suite could be one test or multiple of tests. So this is how it looks like. If you're building a test suite, which means like it's more than one test, there are some code that you can start with before the suite start. Just before all your tests start, you need to run specific code, or before you start a specific test. For every test you need to run, there is a specific set of code that you need to run. And then you have those tools within the MUnit, the set, mock, verify, spy, assert. So I don't want to go through this in detail, but this is basically tells you the basic anatomy, because Lakshmi will go through this in detail. If you look at the left-hand side, there are stuff to be done at the beginning of the flow, and there is a mocking service that you need. If you have like kind of external dependency, you need to take it and set the payload manually in here. This is the mocking. And then the next step is the spy. Spy is like I'm capturing what's happening before and after each processor. And then there is a verify. I'm seeing, I need to validate if this is the right response or no. And then the assert. Oh, this is the validation. This is the verification. And then the assert is like kind of the condition. Are we comparing against the expected versus the actual data at a specific point of time in the flow? I want to end my part of this meetup by going through some best practices for writing unit test. After that, I will pass it to Lakshmi to go ahead and deeper into the MUnit in Studio and the technical part. So make sure that MUnits cover or at least hit those 5 main criteria. It should be targeted. Targeted means I'm testing one thing at a time, right? Ideally, the MUnit should only examine one function or one processor in the Mule flow. And ideally, you should be covering the whole entire flow or any subflow you might have. You need to be test as much as you can. But again, the keyword here is targeted, means I'm testing only one function at a time. If you have like, if your flow is like kind of executing like multiple functions, you need to create multiple tests for this particular flow. Isolated, the code that you will be testing should be isolated from any other areas in the application, all right? And also isolated from any other dependencies or any other external systems. You need to mock everything. You need to mock every external call, either database or another SaaS system or an API. All of these external components should be mocked up. Repeatable and predictable. Unit tested, the unit test should be capable of being run over and over, and assuming that the code under the test and the test itself have not changed, producing the same result every time. No matter how much or how many times you execute the same test, you should get the same exact answer, right? And the expectation is if you come back later on and change the code and you run the MUnit test, ideally, if you didn't break the system, everything should be green. Independent, never make your test dependent of each other. Like, for example, sometimes developers may need to run the unit test in order, because some test like preps something for the next one. This is wrong. So the unit test should be independent of each other and could be run in no particular order, right? And there shouldn't be any assumption that something will be ready before this test will be run. It should be encapsulated. Everything is needed is within the test, and it shouldn't be dependent on any other components that is external to this particular test. Readable. Readable means like make your unit testing easy to read. Make sure that you use good names to it. Make sure that you be consistent in your naming. Give a meaningful and business-friendly names to it. Like if you're testing this particular business function, put the name of the function in as the name of the unit test. Add descriptions and comments as you can, and make sure that whoever the next person who will be working on this project can work with the stuff that you have built easily. Yeah, that's it on my side. Now I'm gonna pass it to Lakshmi to take you through the MUnit within Studio and show you some good stuff on how to create them and how to deal with MUnit within Studio. Lakshmi, please let me know if you can take over.
Yeah, Jimmy. Thank you. I can take over. So I'll share my screen. Just let me know once you can see it. Can you see my screen?
Yes.
Okay. So thank you, Jimmy, for that. So continuing on with the conversation, so MUnit in Studio. So let us look into what are the tools that you can use to create your MUnit test cases for your Mule application in Studio. What are the features that are available? And then we will look into the demo and take a sample application and see how we can generate test cases very easily. We have a cool feature which I'll talk about, which is very, very useful and will reduce the time for creating the test cases. So we'll look at that as well. So in Studio, starting off, there is a very good feature that came out in after in MUnit 2.0. So if your Mule project was generated using API Kit, you can use the API Kit to automatically scaffold an empty MUnit test suite based on the endpoints you described in your API specification. Bear in mind, MUnit does not create the test suite automatically. You have to right-click on the API Kit router, and then you can create an MUnit test suite. It will have basic configurations like your API specification will have the response status codes, right? So it will automatically generate the assertions for that response status code. Like it should be 200 for success or 500 for failure, things like that. So it gives you like a starting point with basic configurations, and you can build on top of that. So this is a useful feature that was available from MUnit 2.0. Okay, so the important tools that you will be using, right, when you create your MUnit test cases. One of the most important tools is mocking. So like Jimmy said, you should not let any external dependencies, you might be making a database, you might be connecting to a database, or you might be making an external HTTP call, or you might have a external connector. So you should not let all these external dependencies affect your MUnit test cases, because unit testing is focused on testing the logic of your code, and it should not be dependent on those external dependencies. So that is not the purpose of basically testing the logic and the flow within your Mule application. So an important aspect is to mock out those dependencies. So that is where the MUnit mock will be used. So it can mock any processor, and it actually gives you the option to return a predefined result instead of executing that processor. So you can control, you can mock the response that you would have actually got from that external dependency in your mock processor. So like I said, it could be a database call, HTTP call, connector call. You can mock the request and response that is expected by the flow. Another important thing that I'll also be showing in the demo is negative test scenarios. So how mocks help you creating your negative test cases. You can actually, so if you have done error handling in your code, where for a negative scenario, if it fails with a particular error and you've handled it in the error handling logic, and you are gracefully handling that error and giving back a custom error message to the user, you want to test that flow as well, right? To ensure that if in case the error happened, the flow is executing properly. So you can use mocks to test your negative scenario as well. You can induce the error. You can actually forcefully induce the error using the mock, and you can assert that the correct custom error message is being returned. So we'll look at that as well when we do the demo. Assertions. Assertions are mainly, to validate that a particular value is what you expect, basically. Yeah. So you're validating the state of the Mule's events.
So you have three type of assertions that you can do. So you have assert that, you have assert expression, and assert equals. So assert that is mainly, so the difference between these three, right? Assert that uses set of inbuilt data v functions. We call them MUnit matchers to do the assertion. So I will show you in the demo. You actually have ready-made data v functions, inbuilt functions to do the comparison, whether to check if your payload is null or not, if you're to do string comparisons, like if this is greater than or less than, if the size of this list is greater than 0. You can do all sort of that by using these inbuilt functions. So these data v functions are already available to you, and when you use assert that, you can make use of those data v functions to do the actual assertion. Assert expression is a facility that allows you to, you can write your own data v expression, and it is a good practice to actually externalize these data v expressions, in your code. So you can have data v expressions in a data v file externally, and you can read that file and then use assert expression to read that file and do the assertion. So this gives you more control, where you control the data weave expressions, and it does the assertion by evaluating the data weave expression that you wrote. You can also have all your data weave. You can have multiple data weave, expressions in one file, and you can refer to all of them in your assert expression. So when in the demo I'll show you both how it looks when we use assert expression and assert that. And thirdly, assert equals is for basic comparisons. Basically just to check if the payload is equal to such and such a thing, or an attribute is equal to such a thing. It's more a basics, basic assertion, basic check. Verify call is another tool that we'll be using. It's very useful. So this is mainly used to check if an event processor was called a specific number of times. So, imagine if you want to, based on certain condition, you want to call a particular flow. And if for some reason you have a bug in your code and it goes into an infinite loop, if you have a verify call there, which actually checks if that flow is called only once, you can catch that error. So it makes sure that whatever you specify, if you want to check that the flow was called only once, or if it was called at least once, or at most twice, you have these three options to configure, and it will let you find out those errors, which like an infinite loop. If you specify this verify call, it is very useful. Spy is basically to spy on the Mule event before and after an event processor is executed. So you can so when you add a spy, you can add a spy for an event processor, and inside the spy you can add assertions, so that if you want the Mule event to be a certain value before the event processor call, you can check it in the assertion. And similarly, you can add another assertion to check the value of the event after the event processor was called. So you're spying before and after an event processor is called. So another example where spying could be used is like if you have an external HTTP request, right? And you can spy the request, the final request, before the call is being made, to ensure that all the required input parameters are present. So that you know that once the call is made, from your end, you have passed all the required data to that endpoint. So you can spy on the request before the call is made, and you can do the assertion to check that it has all the required parameters that you want. So spying is basically to spy on components and checking that the event payload is what it has to be through assertions before and after the event processor is executed. We'll see this also. And this is a very cool feature that came out in 7.5. In fact, I saw a question in the chat. Somebody had asked what's the difference between Studio 7.3 and 7.5. So 7.5 onwards, you have the option to use this test recorder. It is extremely useful because otherwise you have to create an empty test suite. You have to go about creating all the components in the test suite. You have to manually do the mock spies, whatever you want in your test case, right? This will automate all of that. At least 80% of your work will be done by this MUnit test recorder. there are still certain, it's still evolving. There are certain limitations, but primarily it can be used for most use cases, and it is very useful. And I'll show you how to use this in our demo. It actually, what it does, so once it starts recording, it will capture the request. When you fire the request, it will capture the request and the entire processing flow. It will record the entire processing flow and generate the test suite automatically for you, and give you all the components automatically generated. It will also, create the external data v files with the assertions, and it'll have it ready-made for you. So I'll show you all that. Bear in mind, the compatibility for this is Studio 7.5 and Mule Runtime 4.3. So it is a new feature that is very useful, and I've seen many customers relieved by this feature. Okay, now we have the trivia question too. So like Jimmy said, whoever answers first the right question will get a free training or course of their option. So I'm going to go ahead. So which of the following is not a function of MUnit? So allows Mule developers to automate testing of Mule applications, provides the ability to mock different Mule components, scaffolds test suites based on the endpoints described on your API definition, and provides a test coverage on how much a Mule application has been covered by a MUnit test. I am not able to see the chat, but I hope you're starting to record it.
Yeah, I got it.
Oh, sorry, Jimmy, is that you?
Yes, yeah, you can go ahead. You start the answers.
Okay, cool. Okay. All right, so great. Now let's get into the demo. First open my studio. Jimmy, you can see my studio, right? Just to make sure.
Yes, I can.
Okay. So we have a Mule application for our demo. So let me just give you a quick thing. It's a simple application. It receives a HTTP. It has a HTTP listener as the source. It receives an account ID as a URI parameter on the request, and it calls two private flows. The first flow connects to a database and passing that ID as the request and retrieves the details for that ID. And the second flow creates, with the details that were retrieved from the database, it creates a record in Salesforce. So my system is a little bit slow because of this meetup thing. Okay, cool. So let me just repeat. It has a HTTP listener as the source. It receives an account ID as URI parameter. It calls a database in the first private flow, and it does some transformation of the response. And that response is used to create a record in Salesforce, and that's the second flow. And I've also done an error handling. I have an on error continue in case we have Salesforce connectivity issue. We have an order to continue, and we have set the payload as well to a custom error message. Okay, so the first thing that you will be doing is configuring MUnit support for your application. So when you click on configure MUnit Maven support, because Mule 4 are all Mavenized by local by default, and you will want to trigger your MUnit test cases from your continuous integration process. Like Jimmy said, every time you check in your code, you should have automated unit test cases executed, and you should have the code coverage, which we will see. And depending on the success of those execution, you should then package the jar and then deploy it to the next environment. So that will be the first step you do. I had already done that, and If you do that, what you will see in your pom.xml, you will have the appropriate plugins added. So what are the plugins? The two plugins that you need is the MUnit runner, the dependency, sorry, is the MUnit runner and the MUnit tools. These two are needed so that you see the MUnit tools, mock, spy, and thing in your Mule palette. And also you need the Mule MUnit runner to actually run your MUnit test cases. You also will see the MUnit Maven plugin added, and there are a lot of configurations that you can do in this plugin. You can even fail your build. You can specify the coverage percentage that you need. You can control the formats of the coverage report. You can redirect test output to a file. There are many features that you can do here, and all this apply when you trigger your unit test cases from your Maven. So you can when we create test cases and you want to execute when you have multiple test suites, right? And you want to execute only specific test suites from your Maven. So when the Maven command, you can actually specify the test suite name and execute only those test cases. You can do lots of configurations. There is lots of documentation around this. And as I go through, I'll probably tell some, but there is like plenty of configurations which allows you to control what are the things that you can do through Maven. All right, once we have done that, so let's now see, I told you about the test recorder, right? So usually what you would have done, you would have right-clicked on this flow, you would have done create blank test for this flow. But 7.5 Studio and 4.3 version has this option, record test for this flow, and it is like extremely useful. So let's take this, first let's take this small flow. So we have this flow which calls the database, right, with the account ID that was passed in the request. So so if I want to, generate a test case for this, so simple, I just right-click on the flow, record test flow. When I click on this, right, what it does, it launches the embedded Mule runtime. You'll see now, it uses the same embedded Mule runtime, and a pop-up will come. So just give it a second. Bear with me, system is a little bit slow, especially because I'm sharing in this meetup thing. Yeah, it's very slow. Okay, so this is the pop-up that you'll get when you click on the option to start test recorder. So what it's doing, it's waiting for the data. Like I said, it captures a real data and then it records the entire execution and generates the test cases automatically for you. So now let's go ahead and trigger the flow. So I'm just going to, and when you trigger the flow, you'll see it starts recording. It captures the entire execution in the backend, and it has now completed the recording. And now you have the option to configure the test. So when you click on configure the test, the first option you see is your suite name. So this is the suite name that's automatically associated. You can change it. And this is so I had selected the second flow, right? So this is the test case name for the second flow. Next, now see this. So here you have, for the second flow, what I did, I passed the account ID in the request. So it would have got, it would have executed the HTTP listener and the first flow, and first flow would have called the second flow. So the account ID, which was 30, right, which I passed, you see here, I had set it as a variable that is also passed to the second flow. Also in the URI params, the account ID is 30. That is automatically captured, and it has also executed the entire flow. And like I said, it does a database select, right? And for that account ID, what is the details in the database? It has also captured that. So you already have that ready-made. Now let's do, so this is the event processor that calls a database. And like we said, it is very important to mock out your external dependencies. So in a normal case, I would have actually gone and configured the mock in a test suite, right? So here, all you have to do is select the mock this processor. It will automatically configure the payload, which has to be mocked, and also the variables if there are any. Now you click next. You see a summary of all your what is going to be in your test case, and you click finish. There you go. So it has automatically generated the. So let's look at it one by one. So the event, so the input to the flow is automatically set in the set event. And you see here, I talked about assert expression, right? Three types of assertion. So assert expression, where you can have it in a external data v file, and you can read that file in your in your assertion. So if you see here in source test resources, it has already created a folder with the test case name, which we had seen, right? When you did configure test, the test case name. So it has a folder for this specific test, and it has already created if you see set event payload, so it has captured the input, and it has also captured it here. It has set event payload, set event attributes, which should have there was no payload. I just passed the attributes, right? The URI parameter. So you have the URI parameters 30. You have already, it has captured all of that already made, created a data v file, and you have it in your workspace. So you don't have to do all of this. So you have the input, which has the account ID. And the next one, I had mocked it, right? I had mocked, which one I had mocked? I had mocked the DB select. So you would have had to create this mock and select the processor and then select the doc ID, to map the processor and all that. But this automatically does it for you. And if you see here, so what it has to mock, the payload, right? That has to be mocked. That is also present in a data v file, and it has automatically used it in its assertion. So for example, the mock payload, if you see here, the database output has already been captured for you for that particular account ID. So, and then finally the assertion. So the test recorder by default does assert expression, but if you want, you can change it to assert that or assert equals. We'll see that as well. But first, let's see this assert expression. What it does, it basically checks that the payload must be equal to that particular database output, this thing, right? So that's it. I didn't do anything. For a simple flow which calls a database, I mocked the database call, and I generated test cases in like 2 minutes. It's as simple as that. Now let's look at the private flow as well. I want to generate spies and verify calls as well. So let's click on this flow. Yeah, this could be the painful part because my system is behaving very slowly now. Let's give it a couple of minutes. It will again launch the pop-up which to capture the request, and we'll go ahead and create the verify call and this thing as well. Perfect. Okay. So so I'm going to run that thing again. So again, it starts recording. Okay. So now we have the main flow. So same suite, but second the flow, the test case name for the main flow. And if you see now, let's see, I want to do a spy on the transform message. So all I do is spy. So it has already captured the payload before and after uh, the event processor is executed. So all I need to do is click on spy. One thing I forgot to tell you was, if you see here, if you see the flow, like I said, you can actually select. So in this case, I didn't pass any payload, right? So I don't need the payload. I'll just unselect it, because what I need is already there an attribute. So you have the option to do that. If you don't want a particular thing to be passed, you can do that. All right. So I did a spy on the transform message, and the database call, I want to verify that it was called only once. So you have these three options: the verify call, processor, and you have this at most, at least exactly. So I want to ensure that it was called exactly once. And let's also do a mock. I don't want to call the flow. You can also mock flows, like subflows. If you don't want a subflow to be executed, you can do that as well. Not just external dependencies. You can mock the flow itself. So I want to mock this as well. So if you see here, you have a summary of what you will see in your test case. And I do finish. That's it. See how easy it is. It's actually very helpful. It will increase your development speed, because it does. You will still have to do certain configurations, but it does 80% of the work. So let's look at this. So we have the spy that was created for the transfer message, and we have the assertion as well. You have the assertion for the payload, which will, there you go. If you see here, you have all the files, the database files for the specific flow automatically created. You also have the verify call, which checks that this particular flow is called number of processing is equal to 1. All right. So let's. I also because I will run the test suite. But before that, I also want to take this flow, because we have the error scenario over here. So for the error scenario, let me just create a test case, and I'll show you how I can mock the induce the error in that test case and make changes and do a assertion of the custom error message. So just 1 second before we create for this as well. I think it ran out of memory. 1 minute. Okay, I think JVM is having some this thing. Just a minute. So okay, let's. I just it's just running out of memory. Ever since we started this meetup, it's having memory issues. But okay, let's run this test suite. 1 minute. So you can either run a specific test case, or you can run the whole suite together. There you go. It has executed both the test cases, and both of them were successful. And it also created the report for you, coverage report for you. So you can see because I had mocked that third flow, right? The coverage is 66%, and it has executed both the flows. And I'll also want to show you how to run it from Maven. But before that, I want to do the negative scenario. There seems to be this thing. I'll give it one more try. Otherwise, I'll just restart my studio. Just give me a minute. Yeah, it's the memories. Let me just do one thing. Okay, guys, just 1 minute. Let me start my.
Sometimes Chrome takes much memory, Lakshmi, if you want to close it for now. But don't close
Yeah. Actually, ever since this meetup thing, right? I think it's taking even more memory.
Maybe close the other tabs that you don't want.
Yeah, I closed literally everything. I don't have it.
Oh, keep those.
Let's look at the questions while this thing opens up. Standard best practice for creating batch scope. I actually have a link for that. In fact, one of our attendees, I think Manik, has written that. It's very useful for testing batch scopes. I'll share that with you. Like what are the nuances? Batch can be proved tricky. So what are the considerations that we have to take in place? I have that. I'll share that link with you. Or Manik, because you're already there, you can paste it in the chat. Yeah. All right. Hopefully, I don't have memory issues now. Let's see. Okay. Don't get frightened by this. Usually, it's not. I mean, I've used the same machine. It's pretty fast. I don't know if it's because I'm sharing my screen as well in this new Meetup software, but that seems to add to the latency. So, okay, let's come up. All right, so let's do one more for this. It's recording. Yeah, there you go. All right. The reason I want to do this is I want to show you how to create a negative scenario, negative test case. So, no, okay. You see what happened because of lack of memory? It didn't. This thing, just give me a minute. It didn't recognize that Salesforce connector. 1 minute. I'm sure you guys would have faced this as well. Just opening and closing the project will solve that. Okay, cool. Sorry guys, one last time. Okay, let me actually also look at the questions in the meantime. No, you should create MUnit for every flow possible, for a subflow, for a main flow, for a private flow. If your main flow has conditions like based on a choice router or a scatter gather, every path has to be tested. So don't just create it for the main flows. The aim goal here is to test every single testable part that in your flow. Even if you have separate event processes, you can create spy like I created on a transform message. You should create if that is critical, you have to create a test case for that to spy on that component. So up to the smallest component possible, you should create your MUnit test cases. Test resources, yes, as part of the build. No, so that's where the resources specific to your MUnit test cases reside. So you will have source MUnit test where your test cases will reside, and the resources that are used by your test cases will reside in your source test resources folder. And okay, any other question? Sure. Assertions happen in behavior and validation. Do they induce similar results in terms of? That's what I want to show you. I want to show you where I'll induce the failure and how I'll assert that the thing is failing, is the expected payload is being returned. Because testing negative scenarios are also very important. Yeah, this time I really hope we can do it. Okay, so this is for the third flow, which is called Salesforce. Thankfully, yeah, it was able to recognize. So like I said, all I want to do. What I want to do, I have the Salesforce connectivity thing set up, right? I've already handled that error. So now, if I want to test that, if in case of a Salesforce connectivity issue, is my flow behaving as expected? So what I can do is, so I've created the mock for the positive scenario, positive path, right? So if you see here, yeah, it has already created the mock. This is for the mock payload for the positive scenario. So what I'll do, if you see here, I have the error handling for the Salesforce connectivity issue. So I have already defined the type of error. So what I'll do, I'll remove this. I don't want to test the happy path. This test case is specifically for the negative scenario. So if you see this option, error, so you can actually induce the error by induce whatever error you want by specifying it over here. And what I want to do, I'll also, I told you about assert that, right? So I'll remove this assert payload. I don't want this assert payload. I actually want to assert that the final message, right, is equal to, so the payload, expression payload, is it went into the error handling on error continue, and I want to ensure that it has set the message to what the error message to what was the custom error message that I set. So this is where the in assert that I said you can use those inbuilt data weave functions, right? So there, if you do control space, you'll see the list of data weave functions that are available, and you can. In this case, I'm doing a string comparison, so I will just do equals ignore case. And I'll just give that string which I've defined there. So in the error handler, I have set a custom message. So in the assert that, I'll just ensure that the final payload is equal to that. All right. So let's now run this test case as well. So you're inducing the error and you're checking that your error handler got executed, and you're actually verifying that the final payload is what you expect. You can actually see in the logs that the Salesforce connectivity error is being induced, and it will do the assertion. So the main components that you'll be using is spy, verify call. Run custom is if you have a custom Java assertion that you want to run, you can, in your data v file, you can use run custom to actually read that and execute it. And sleep is basically if you want to simulate a delay in your test case, a 10-second delay, like thread.sleep, right? You can use that to simulate a delay and then execute it. And then, of course, the assertions are very important. These are the main things that you'll be using primarily in your test cases. You see here, I don't know if you could see, it actually induced the error. I'll show it to you once it's complete. Okay, so first of all, the test case was successful because it induced the error, and my payload was equal to that. And if you see here, you see Salesforce connectivity was actually the error type that was induced in your test case. So this is how you can use mock to generate negative test cases and test your have your negative scenarios tested. So some more options that you have in your test cases is, for example, you can let's look at the properties. Yeah, so you can please bear in mind, make sure to give a proper description so that when you have other developers running, executing the same, they know what it is for. You can ignore this test. If you select by default it's false, you can, if in this test suite you don't want this test case to be executed, you can measure it, specify it here. You can tag. Tag is nothing but categorization. So if you want to categorize a couple of test cases as success scenarios and some as failure, and in Maven you can actually specify the tag when you let me show you in Maven how to execute. So in Maven, nothing. All I have to do is, so once you check in your code, your build server will execute these Maven commands. So I will do a Maven, what's the Maven clean verify? Yeah. So for this project, and what it will do, it will nothing. It will just execute the test cases that we've already configured. And in this Maven clean verify, right, you can pass those parameters which I said. So like you can pass the tag, you can pass the test suite name. If you want, if you have like 5 test suites and you want only one test suite to execute it, you can give that name alone. You can also pass the test case name if you want specific test case name to be executed. Okay, and this option is actually if you want to actually check that your test case is throwing an error, then you need to specify that the expected error is this. So you have the list of errors here. You need to specify that this error is expected, and that will and if it throws as expected, then that will ensure that the test case is successful. So you're ensuring that your test case is throwing some error. Like for example, if you have object store and you're reading a file from object store, and the value is actually the key itself is null, so it's going to throw an error, right? So certain things you can such things you can ensure that the test case throws the error it is supposed to be thrown, and to tell the test case that this error is expected, you can specify it here. And enabling flow sources is so MUnit cannot how do I say, MUnit cannot have HTTP listeners or schedulers as part of its test case. So if you want those to be run in your MUnit, you have to specify the flow where those are present so that it can initialize the HTTP listener and execute that. Basically for HTTP listeners and schedulers, so you cannot you cannot have them in your MUnit test cases. So in those cases, you will have to assume that you have a flow triggered by a scheduler component, and you want to validate that your flow is being triggered correctly. So you have to make sure that you enable the flow sources, and you give the name of the flow that has the scheduler component, and only then MUnit will be able to get triggered by the scheduler. And some more options. So let's see if the Maven thing got executed. Yeah, if you see here, it has executed all the cases. That 3 test cases were executed. The coverage report. So if you see in the pom.xml, I had given the coverage format as console. So you have options to specify here. So you can specify HTML, JSON console. I have given as console, and that's why you see it here. So similarly, in your build server, if you want it to be written right to a specific file, you can specify this, and you can also give the file location. You have all those options. You have lots of options in Maven that you can specify in addition to what I've told. Like for example, you can, what can you do? You can set up coverage, the coverage report. You can actually, very important thing. So you saw the coverage report, right? You saw it was, where is it? In fact, let me, I ran the Maven, right? So I'm doing a refresh. So what the Maven would have done is collected all the reports, and you can actually see the summary here. So if you want your test to fail, if it is not 80% coverage, you can do that. You can specify in your pom.xml. You can specify a tag called fail build, and you can give a value as true or false. So you can fail it if you can specify additional tags like required application coverage, required resource coverage, required flow coverage, and the percentage you can specify that 75% or 80%. So what it will do, if you're given fail build as true, if your coverage is not that particular percentage, it will fail the build. Or if you can also set the option to not fail the build but have a warning printed out saying that coverage is not so much, but you're still not failing the build. We have that option as well. So it's important, right? Code coverage, and I plan to, always have code coverage, at least 80% code coverage, because it is important that you ensure all your components are tested out. And then you can also ignore flows. You have tags like ignore flows in your POM, which you can specify, and you can ignore specific flows if you want. What else? I've told a lot. You can run specific MUnit test suites. You can skip all tests. They're all Maven commands. You can pass them as parameters that you can specify and run in your Maven commands from your build server. And then, of course, the coverage, which you just saw, and you can control the coverage as well. So it's pretty simple, especially with the test recorder. It's very simple. You can 80% of the work is done, I would say. You just need to do some configurations in case of negative test cases, how I changed it, negative scenario. These things you'll have to do. But primarily, it does most of the work for you. I hope you start inculcating unit test cases in your SDLC and automating them from your continuous integration process. So that every time you're checking the code, you have a set of automated test cases that are run by default, and you know that the changes you made or anybody else made has not broken anything. And then maybe you can trigger integration test cases once you move to various environments. Instead of for integration testing, that could you can do that when you package when you move it to QA and stage to ensure that end-to-end functionality works. That's all I had. So let's look at the trivia question 3.
Last winner, pay attention.
Yep. So out of the 3 assertions which I told you, which one uses a set of data view functions to define the assertion conditions?
People start to shoot numbers. Oh my God.
Okay.
All right, I think people have started already to put their answers. Thank you, Lakshmi, for the demo.
Yep.
It was really great.
Yeah.
For attending the meeting, we're gonna go through the Q&A session shortly. Please, in the comment section, please let us hear your feedback on the meetup. Has it met your expectations? Any improvements you suggest for the future? Also, again, I'm going to keep repeating this. I posted in the comments, and then I'm going to say it again. If you would like to talk in any of the future meetups, please let me know, and I will contact you. Thank you all. So,
Jimmy, have we noted down the winners?
Yes, I got the winners. We will go through them. Maybe not the last one. I hope you can help me with the last question.
The last question. Okay, let's go question by question if you want. Just because
let's keep this after we finish the question section. Mandy was great. She collected all the questions from the group. I will DM the questions to you, Lakshmi, so you and me can go through them.
Okay.
1 second.
I think we should turn on our cameras for the Q&A.
Yeah, for sure. So Lakshmi, I'm gonna DM them to you, and you can go them one by one. This is the first one. Can you see them on the chat?
I didn't get it. Jimmy, are you
on the chat? On the chat.
So in your chat messages, you click on the chat tab. And
yeah. Oh, direct messages. Okay, sorry. Yeah.
How MUnit gets impacted by
I answered this question, right? So at least for 7.5, the test recorder is a feature that is available, which is not available in older Studio versions. And if you see the release notes, you should be able to see the compatibility of the MUnit version with the corresponding Studio version. But the main thing that I can think of is after 7.5, this test recorder was introduced. It's not available in the older versions, and it's pretty cool.
Good. I can take the second question. So the question is, if all external resources are supposed to be mocked, what is then the best practice for checking the availability and expected format of the external resources? So this is basically the integration testing, where you test the connectivity between the systems. So you need to build an integration test where it covers all the connected pieces and make sure the data flows across the system. This is not meant to be for unit testing, that's for integration testing. Next question, Lakshmi.
Is the recorder still yeah, as of now, it only.
Can you read the question for everyone?
Yeah. Is the recorder still supporting only happy cases? So as per of my thing, yes, the recorder supports only happy cases. So there are some limitations to the recorder. I'll probably tell it. So one, you cannot, you cannot if your tests, you cannot create tests for flows with mule errors inside the flow if you already have an error in the flow, this test recorder will actually throw up a message saying you have an error, fix it, and then you can use the recorder to generate the test cases. So if you already have an error in your flow, you cannot use the recorder to generate the test cases. Second thing, I think for each processor, it does not support mocking a message before and inside a for each processor. So in that case, what you can do, if you saw the mock that I used, right? You have an option in the mock. So if you want to, so imagine this use case: you have a for each, and you want in each of those iterations, you want to pass different requests. So what you can do, you have the option in the mock to so mock, what it does a mock of a particular component, and it specifies the payload that has to be returned. So you also have an option to invoke a flow within those after the mocking is done. So in the case of for each, you can actually specify the flow to be invoked, and in the flow, based on the counter of that for each, you can specify the payload that has to be passed. So that is an option that you can use for each to pass dynamic payloads for each iteration. So you can use the iteration counter as the parameter, and you can have a choice router in that flow, use the iteration counter, and then pass the payloads for each iteration. So, but the test recorder does not support for each processor. Apart from that,
let's go to.
Yep.
So, sorry, I'm sorry, Mandy. That was supposed to be. Do you want to read question 4, Mandy?
Yeah.
I pasted
question 4.
Yeah.
Is there any difference between executing MUnit tests through Studio and Maven? Someone said from experience, there are scenarios where MUnit tests are successful in Studio, but they fail during the test phase in Maven.
Ideally, they should not.
Yeah. Configuration issue.
So Maven, it does the same thing. When you do a Maven clean test or Maven clean verify or a Maven clean package, it just goes through the various life cycles, but it basically executes the test suite that you already have configured. Ideally, there should be no difference, and it should be executing the same way, and you run it in Studio. I don't know if you have passed some parameters to this Maven command, which could have, which can actually be causing the issue. But apart from that, I am not. I think it should not be any change. There should not be any change in the way it executes.
All right. Question 5.
Somebody said that would happen if there are multiple test XML files and the flow are sharing some same beans.
You mean domains? So even domains are fully supported. You should not have any problem when you test, flows that use domains. But it could be a specific scenario, one-off scenario. Question 5, I think, Jimmy, we already answered. I answered it during my demo, where we don't create MUnit just for main flows. We have to create
I might recommend you read the question again out loud so everybody knows which question we're addressing. So, Mandy, go ahead, question 6.
The question is, we usually create MUnit for the main flows, right? And Lakshmi did answer that during his demo. And the answer is no, you create MUnit for every flow, not just the main flow, to get good test coverage.
Yes.
Okay. Question 6 is there a test or resource folder where the files are generated that is part of the build?
Yeah. This also I answered. So test, you have the MUnit source test where you have your test cases sitting, and the configurations, the data files that your test cases use, those are inside the source test resources folder.
Okay. Question 7 is Is there any standard or best practice for creating MUnit tests for flows and subflows using batch scope? As batch scope is running on separate thread in MUnit test, it will not be able to assert or verify anything in batch scope, as it might end first before the batch scope finished its execution.
Yeah, this is where I had, I think Manik had also given the link. It talks, a lot to the nuances of creating test cases for batch. We had posted it in the chat, the link. That's a good article. It's been helpful for many in my experience. So that talks about what are the considerations you have to take for if you're generating test cases for batch. It was already shared, Mandy, in the chat.
Okay. Question 8 is, assertions happen in the SPY component and in the validation part. So do they induce similar results in terms of failing the tests?
Yes, if an assertion fails, it's going to fail the test because you get the assertion failed error. So basically it behaves the same way, but you can use it inside an SPY to assert, SPY on the payloads and do the assertion, or you can use it in the validation where you actually validate the final output. But in either case, if the assertion failed, it will throw the Java lang assertion error.
Okay. The last question is synchronize, run, and wait available for Mule 4?
I'm not sure, but maybe that is where you can use the sleep for if you want to induce any wait. Maybe we can take up this question and check. I'm not sure about this. Jimmy, do you have any idea?
No, maybe we can take it and provide the answer later. If we know who answered it, maybe I can pick it up from the chat and we can address the person supposed to.
Yeah, I will.
Let me see.
Get you the person who asked.
We'll figure it out. I have a copy of the chat.
Okay.
Okay, I think this was the last question.
Yeah.
Anything
Jimmy also asked about topics that you guys want to learn about in the future, and he's going to take them back, right, Jimmy? And
yeah, so I have selected the following topics: data weave, RTF, error handling, Salesforce bulk integration patterns, best practices on error handling and email notifications, OAuth and OAuth and identity management. Again, somebody requested error handling, and then last one was API manager and different policies it supports. I hope if any one of you of the attendees here can speak to any of those topics or any other topics, please approach me or put your name here in the chat and I will approach you. So we want to enrich the conversation and add more topics to the future meetups. I cannot be the speaker on all of the events. So I would like your, so if there is any partners attending the meetup here with us, so we encourage you as well to step in and participate. Yeah, and let us know. Let us know in the chat also what we've done. If how do you think about this session? You like it? You don't like it? Did it meet your expectation, or you would like to see any improvement in the future? Would like to hear from you in the comment section as well. Thank you.
Yes, I'd like to add that being a speaker, you don't have to be an expert in the area. You can even lead the session to answer questions you have and possibly make it a working session too, and bounce ideas off of others.
Yeah.
Yep. Cool. Jimmy, do you want to announce the winners?
Yeah, let's go ahead, Matt. Do you want Mandy go through this? So maybe you can read the question and the correct answer and announce the winner.
Yeah, do you want to explain why the correct answer is what it is before I announce the winner?
Okay, so the first question was, what is a form of testing that measures system performance when the workload suddenly increases quickly? And the quick answer, and the right answer for this one is spike testing. So many people answered the right one, but we'll take the first winner. So basically, as I said, like spike testing, test like a load on a certain or a short period of time. And the use cases for this is if you're doing ETL, or if you're like doing testing for a system that experiences a large amount of traffic within a certain amount of time.
Yeah. And spike testing is a form of stress testing, though. Like if the answer to stress testing, would they be wrong?
Yeah, they are. Yeah, it's right. You're right. It's part of. So spike testing is part of the performance. All of these are considered performance testing, but each one of those like address specific area.
Okay.
All right.
So the winner of question number 1 is, I hope I say this right, Santosh Devela. So congratulations, Santosh. The second question, which of the following is not a function of MUnit? Jimmy, what was the correct answer?
Yeah, the right answer for this one is number C. Scaffolds test suites based on the endpoints described on your API definition. And it's actually the API kit who generates the test suite. All of the other answers are part of the functionality of MUnit. So number C is the right one.
Okay. And the winner for that question is Riteshwari Gaunshind. So congratulations, Riteshwari. The third question is, which MUnit tool's assert event processor uses a set of data weave functions to define the assertion conditions for any value in the expression? What was the right answer?
Go ahead, Lakshmi.
Yeah. The right answer was assert that. I know people could have got confused with assert expression, but bear in mind, the question is which processor uses data weave functions. So the set of data weave functions that are available, right? So we saw the MUnit matchers when we did the assert that. So that is the right answer. Assert expression actually allows you to create data weave expressions and then externalize them, and then use that. You can read those files and then do it. But the processor that uses the already available data weave functions is assert that. And the winner is Eddie Luang.
So congratulations to all three of you.
Yeah.
We'll provide your names and emails. Actually, if you guys, the winners can send me your emails, because I actually can't see them when you register. They're blocked out for some reason.
It's the third question, Lakshmi.
Oh, sorry.
I will correct you. So the winner of the third question is Eddie.
Yeah.
Okay. So we hope you enjoyed this session. And like Jimmy said, please, if you want to present next time, let him or myself know. And we're looking forward to organizing a meetup at least every quarter and having different speakers all the time and having more working sessions so you guys can bounce ideas off one another and continue improving your MuleSoft knowledge to become a Muley.
Thank you all for attending. Thank you.
Thank you, Mandy, for organizing the event. Thank you, Lakshmi, for the great demo. Thank you, everyone, and we hope to see you in the next event. Have a great weekend.